Hi guys, this is Mr. Urrego, and today we're doing reference angles. So we're going to find the reference angles in the four quadrants. So this is Q1, this is Q2, this is Q3, and this is Q4. Alright, I'll find reference angles in the four quadrants. Now, let's start with the beginning. If let's say that you see the blue one, that's my angle, that we're going to call that angle theta. If my angle is in the first quadrant, my reference angle is the same angle as well. So my angle, my reference angle are the same. Why? Because my reference angle is nothing more than the angle that the terminal side will make with the x-axis, whichever is closest, the positive x-axis or the negative x-axis. In Q1, it's going to be this side, so the angle itself and the reference angle is the same. So we don't use that as a reference angle. We'll look at the reference angle in quadrant 2, quadrant 3, and quadrant 4. Let's go. So let's pretend that this angle, the angle blue, is my angle theta. The one that's going to be the question. The question will be, find the reference angle to angle theta. Let's pretend that that angle is 120 degrees. Okay, so how do I know how much is my reference angle? So my reference angle is always, remember, this is my angle, initial side and terminal side. So I need to know how much is the angle that will make the terminal side with the x-axis. So this is my reference angle. So in that case, if this is 120, how much is missing to 180? You do 180 minus 120, and that's going to give you 60 degrees, and that's my reference angle, which I'm going to call it theta prime, 60 degrees. Let's go to quadrant 3. Initial, terminal. Okay, let's call this theta 240 degrees, for example. So the blue angle is 240, it landed in Q3. I want to find the reference angle, therefore I got to go back between my terminal and the x-axis. So I got to find this. In this case, because this is 240 is greater than 180, what I do is I do 240 minus 180, and that's going to give me 60 degrees. So this reference angle, which I can call in theta prime, is 60 degrees in this case, always with the x-axis. Now in quadrant 4, blue angle, let's call that 300. Alright, so theta, my angle is 300, and they're asking me, right, find the reference angle. Initial, terminal, right, and the blue angle is my angle. What's the reference angle? Because it's past 180 and it's closer to the x positive side, then I gotta find out how much is this angle that the terminal makes with the x-axis. So if the whole revolution is 360, then what I do is I take 360 minus 300, and that's gonna give me 60 degrees. So in this case, my reference angle is 60 degrees, and I'm calling that theta prime. Okay, let's do a couple examples. Let's find the reference angle to theta, and let's call theta, let's say 345 degrees. Okay, so the first thing I need to do is I need to find this angle. So this is 90, 180, 270, so 345 is around here. So let's call 345 right there, and this is my initial side. So all this is 345. The closest axis is the positive side, so this will be my theta prime. Alright, so what I do is I take 360 minus 345, and that's going to give me 15 degrees. So this reference angle is 15 degrees. Alright, let's do one more. Theta is 5 pi over 6. Okay, so 5 pi over 6, I know that from here to here is pi. That means 5 pi over 6 is less than that. So it's going to be around there, let's say. And this is going to be 5 pi over 6. Okay? Now my reference angle is this terminal with the x-axis. That means this is my theta prime. So I need to find out how much is that angle. Because this is almost 180, almost pi. What I do, I take pi and I subtract minus 5 pi over 6. Because I have my denominator 6, I need to turn this pi into 6's. Times 6 over 6, so it's 6 pi over 6. Once I have the same denominator, I keep the denominator and I subtract the top. 6 minus 5 gives me 1 pi. So that means that my reference angle is pi over 6. What about a negative angle? Let's say that my angle theta, and I'm looking for the reference angle to this angle, right, is negative 135 degrees. Now, positive angles, I go here, but negative, so these are positive angles. Negative, go the other way. Negative 135, so this is negative 90. Negative 135 is almost here, so this is halfway over here. So this is my angle from here to here. This is a negative 135 degrees. Remember, I'm going clockwise. So the reference angle is whatever this side, terminal side, makes with the x-axis. How much is that? So I'm going to take 180 minus 135, right? It's always, if it's less than 180, so you subtract it to 180. If I have a 240, which is greater, then I subtract 180. So in this case, I'm going to have 180 minus this is 45 degrees. So my reference angle is 45 degrees, okay? And the reference angle is always positive. And we're going to use the reference angles to find trig functions. Let's say that my reference angle is 2.5 radians. So now I'm not giving you pi radians, I'm not giving you degrees, I'm giving you 2.5 as a decimal. Therefore, I don't use pi, I use how much is pi as a decimal form, which is 3.14. So from here to here, this is pi, which is also 3.14. If you notice, 2.5, half of 3.14 is 1.67. So around here will be 1.67. And 2.5 is much greater than that, okay? Therefore, 2.5 could be something around here, all right? So standard form from here to here, I'm going to call that 2.5 radians, all right? That's my angle. So what I do is, this is my reference angle with the x-axis always. It doesn't matter if it's a positive or negative, but it's always with the x-axis. So in that case, I'm going to take 3.14 and subtract 2.5. And that's going to give me 0.64. So my reference angle, which I'm calling that prime, is 0.64. What about if the angle theta is greater than 1 revolution? Let me give an example. What about if I have something like this? If my angle right now is 580 degrees. If you notice, that's a big number. So if I go around one time, it's going to be 360 degrees. And this is much bigger than that. So what I do is, because I know that this is bigger than 360, I take 580 and I subtract 1 revolution. Okay? So 580 minus 360, and I'm going to get 220. And now I work with 220. 220 again, this is 180, and I know that 220 is bigger than that, so I take 220 minus 180, and I get 40 degrees. So if this is 180, 220 is going to be around here. So this is going to be 220 degrees. Subtract 180, and that with the x-axis is going to make a 40-degree angle. All right, let's work in another one in terms of pi radians. What if I have 8 pi over 3? Okay, again, bigger than 1 revolution. Because this is divided by 3, pi radians, pi over 3, then I know that my pi is the same as 3 pi over 3. And I'm doing this because my denominator is 3. So if this top is 3 pi over 3, the bottom is also 3 pi over 3. 3 pi over 3 and 3 pi over 3 gives me 6 pi over 3. So if I start here, that's 3 and 3 gives me 6 pi over 3. And I have 8. So I have to do 8 pi over 3 minus 6 pi over 3, which is going to give me 2 pi over 3. So my resultant angle is 2 pi over 3, which I know that it's going to be something around here. Okay, so let me erase that and let me do the 2 pi over 3. So 2 pi over 3 is going to be something like here. 2 pi over 3 is what, 120. So this is 2 pi over 3. we said that my reference angle is always with the x-axis. Therefore, if this is 2 pi over 3, how much is this? The whole thing is 3 pi over 3. And this angle here is 2 pi over 3. Therefore, my reference angles, if I subtract it, I'm going to get pi over 3, and that's my reference angle, pi over 3. Okay? Let's do the last one. What about if I have a negative angle? Negative 13 pi over 6. So now I have my denominator 6's. Therefore, my pi is the same as 6 pi over 6. But because this is negative, that means I gotta go the other way. So this is negative 6 pi over 6, and another 6 pi over 6 is gonna give me negative 12 pi over 6, and I need to get to 13. Therefore, I need to go one more. Right? So all the way up to here is going to be negative 13 pi over 6. You just notice that from 12 to 13, this reference angle is going to be pi over 6. Always a positive angle. All right? Okay, guys, subscribe to the channel, like the video, ask me questions. Our next video, let's see, is going to be using reference angles to evaluate trigonometric functions. So what we just learned, we're going to use it to find sine, cosine, tangent of any angle. By the way, reference angles are very common and are very useful, so make sure you understand them. All right? I'll see you in the next one. Take care. Bye-bye.